So what are we doing? Might just be again a short one. So today we're basically going to be staring at this equation. That's it. That's all we're gonna. That's all we'll do. No, just kidding. But I just kind of had this idea this morning. I thought, like, why am I even assuming it's just going to be 3 dimensions? Why I can't just do like 2 dimensions and then see what happens? Like, why it can't just be 2D? You know. And then really it is that kind of cone thing that we said about. So. But like 2D and then it's still 3D, right? So still why wouldn't it just be 1D? You know, that's kind of the point. I mean, it's clearly not because it's bold, and that's what the convention means, as far as I know. Not polar, but cylindrical coordinates. Change our variables. Okay, so this is okay. This one is a bit different. So it says what is even theta though, right? Change our variables. The region E of which we integrate becomes what was this thing with use here? What was that? Essentially the boundaries, right? That's what you want to do. This is what I checked last time. So what we're building to how that works. Yeah, it's definitely confusing. Okay, you can choose to express the bounds in the function using spherical coordinates. You cannot just replace dB with these. You must also remember that the r squared sinus term. Let's work off of the assumption that we know these. And again, I think that these were kind of like known for us, that the one was like 2 pi and another one was pi, right? So which one was it? So which one was it? Constant. Okay, so theta is 2 pi. Okay, so let's do it like this. So let's try to do it like these. So this guy here, and so what we have is so we have this r thing here, and so the first thing is we integrate r, but again, so the final expression is actually these times r squared. Do you like that? Times sine of how do I call these angles? I'll call them B and C, I guess. B and C. So B, C, B, C. So this is going to be C. Sine side C. If I do these, what do I get when I run these? Shell Python x2 1a squared. Okay, yeah, whatever. So r squared sin c. Okay, cool. So I have these, and the first thing we do is we integrate with dr. So what we're doing is we're doing the integration on r between 0 and infinite. This is really the values that r can take. Then we're doing the integration on c, which is basically essentially S3 would be S2. We integrate over C between 0 and pi. Yeah, but when does then theta come from? This is where is then the reformulation of these? So how do they do this here? They first work on these. then they work on that, and then, but there's no d theta here. How does that work? How can you solve? Can you just solve like this? Like what? There's not even theta anywhere. So I guess it's just because it's constant. Whatever. I don't think that's gonna work. I definitely don't think that's gonna work. S3 on on B being 0 and 2 pi, and then basically say p prints S4. I'm sure that's not gonna work out. Why would it? It's gonna break like Wait a second. This alpha what? 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 Wait a second. What? Ooh, that might be it. Maybe. And now we want to solve, right? So now we want S5. No, that can't be true. If this works, then I'm gonna be like, what the hell is going on? For n, and then p print S5. Well. What the fuck? I think that worked. Almost. Really? Almost. So the solution here is this shit. Is that equivalent? What do we have here? So it's like, so here we have, what do we have here? So we have paint. Wait a second. I definitely want to understand this better. But like, so this is a to the 2/3 divided by pi to the 1/2. And so the solution we have is what? We have basically a to the 3rd divided that by pi, and this to the 3. No, okay. Ugh. It's not exactly the same. 3, 2, but it's very S32. Sorry, this is actually 3, 2. God, it's almost there. Something's like it's almost there. It's almost there. Almost there. See you next time. Almost there.